Welcome. Today we'll examine the critical requirements of NFPA 70B for electrical grounding and lightning protection maintenance. This presentation is brought to you by ENS Grounding Solutions, your partner in electrical safety and compliance. On January 16, 2023, NFPA 70B underwent a fundamental transformation. What was once a recommended practice became a mandatory standard, shifting from advisory should language to enforceable shall requirements. This standard now establishes minimum requirements for electrical equipment maintenance programs across industrial, commercial, institutional, and large multifamily residential facilities. It's enforceable by OSHA, state and local authorities, insurance companies, and through liability standards. Critically, there are no exemptions for small companies. All covered facilities must comply, regardless of size. Remember, proper maintenance protects more people than any other electrical safety measure. Who must comply with NFPA 70B? The scope is comprehensive. High-voltage facilities including substations, power plants, solar farms, and wind farms. Industrial plants such as manufacturing facilities, processing plants, and refineries. Commercial buildings including offices, retail centers, and warehouses. Institutional facilities like hospitals, schools, universities, and government buildings. And large multifamily residential complexes. The key facts: small companies are not exempt. Compliance is required regardless of company size. Enforcement comes through OSHA, state and local codes, and insurance requirements. Every facility must establish a formal electrical maintenance program with 8 mandatory elements. First, designate an EMP coordinator responsible for program implementation and oversight. Second, conduct equipment condition assessments to classify equipment as condition 1, 2, or 3. Third, develop written maintenance procedures for all electrical equipment types. Fourth, create maintenance schedules based on Table 9.2.2 or manufacturer recommendations. Fifth, maintain comprehensive documentation including maintenance logs, test results, and corrective actions. Sixth, ensure qualified personnel perform all maintenance. Training is mandatory. Seventh, update system studies including short circuit, coordination, and arc flash analyses every 5 years minimum. And eighth, implement a continuous improvement process based on failures and findings. Equipment condition assessment determines maintenance frequency through 3 classifications. Condition 1 represents like new equipment: clean, moisture-free, secure, with no unresolved monitoring notifications and previous maintenance performed on schedule. This results in the longest maintenance intervals, such as 60-month electrical testing. Condition 2 indicates minor deviations. Maintenance results showing trends requiring increased frequency, or prior maintenance revealing issues requiring major repairs. This results in moderate intervals, such as 36-month electrical testing. Condition 3 signals significant issues: missed maintenance for 2 consecutive cycles, equipment failure that could endanger personnel, or operation in harsh environments. This requires the shortest intervals, such as 12-month electrical testing. Above-grade grounding systems require regular visual and mechanical inspection of several critical components: grounding electrode conductors, equipment grounding conductors, grounding bus bars and switchgear and panel boards, and bonding jumpers and visible connections. Inspection tasks include corrosion assessment to check for resistance increases, physical damage inspection for cuts, abrasions, or crushing, verification that all bolted connections are tight, torque verification to manufacturer specifications, and bonding continuity verification that jumpers are properly connected. Maintenance intervals for visual inspection. Condition 1 and 2 require 12-month intervals, while Condition 3 requires 6-month intervals. Below-grade grounding systems require electrical testing to verify integrity. These systems include ground rods or driven electrodes, ground rings buried around building perimeters, ground grids in substations complying with IEEE Standard 80, concrete-encased electrodes known as UFR grounds, and buried connections using exothermic welds or compression connectors. Testing methods include ground resistance testing using the fall of potential method, soil resistivity testing using the Wenner 4-point method, continuity testing to verify buried connections, and ground potential rise analysis using DEGS software for high-voltage facilities. Acceptable resistance values vary. General commercial and industrial facilities require 25 ohms or less per NEC 250.53. Substations and high-voltage facilities require 1 to 5 ohms per IEEE standard 80, and telecommunications facilities require less than 5 ohms. Maintenance intervals for electrical testing. Condition 1 requires 60 months, Condition 2 requires 36 months, and Condition 3 requires 12 months. Lightning protection systems require annual inspections and periodic in-depth testing. These systems consist of 5 key components: air terminals or lightning rods that intercept strikes at the highest points, main and down conductors providing a direct path to the grounding system, bonding connections that bond the LPS to other grounded metal systems, grounding electrodes that dissipate lightning current into earth, and surge protection devices that protect against transient overvoltages. Inspection frequency varies by facility type. Annual visual inspections check for bending, cracking, corrosion, loose connections, and roof penetration integrity. In-depth inspections every 3 to 5 years include continuity testing, ground resistance measurement, SPD testing, and compliance verification. Critical facilities such as hospitals, airports, and data centers require annual in-depth inspections. Post-event inspections are mandatory after lightning strikes, severe weather, or structural modifications. NFPA 70B Table 9.2.2 specifies mandatory maintenance intervals by equipment type and condition. For grounding systems, visual inspection requires 12 months for conditions 1 and 2 and 6 months for condition 3. Ground resistance testing requires 60 months for condition 1, 36 months for condition 2, and 12 months for condition 3. For switchgear and circuit breakers, visual inspection follows the same 12-month and 6-month pattern, while electrical testing requires 60, 36, and 12 months respectively. For transformers, infrared thermography requires 12-month and 6-month intervals, while oil testing for oil-filled units requires 36, 24, and 12 months. An important note: manufacturer recommendations take precedence over Table 9.2.2 intervals. All maintenance personnel must be qualified. NFPA 70E defines a qualified person as one who has demonstrated skills and knowledge related to the construction and operation of electrical equipment and installations, and has received safety training to identify and avoid the hazards involved. Required qualifications include deep understanding of equipment construction and operation, knowledge of maintenance procedures and testing methods, expertise in NFPA 70, 70B, 70E, 780, and IEEE standards, and comprehensive awareness of electrical hazards including shock and arc flash. Training options exist for all companies, including small businesses. Hire licensed electrical contractors with qualified electricians. Send employees to NFPA 70B and 70E training courses. Utilize trade union training programs such as IBEW apprenticeships or complete manufacturer-specific training for specialized equipment. Specialized training is required for infrared thermography certification, protective relay testing, and high-voltage equipment maintenance above 1,000 volts. There are no exemptions. Small companies must ensure personnel are qualified. Documentation and record-keeping are mandatory, with no exemptions for small companies. Required documentation includes 9 elements: a written electrical safety program addressing maintenance conditions, personnel responsibilities identifying the EMP coordinator and maintenance staff, an equipment inventory with type, location, criticality, and operating environment, written maintenance procedures with step-by-step instructions and safety precautions, maintenance logs recording date, personnel, tasks, test results, deficiencies, and corrective actions. Also required: system studies including single-line diagrams, short circuit, coordination, and arc flash analyses updated every 5 years, a visual indication system using QR codes or decals showing last maintenance date and next due date, corrective action records documenting repairs, parts replaced, and root cause analysis, and program review records for continuous improvement. Records retention best practices. Maintain maintenance records for the life of equipment plus 5 years. Test results for a minimum of 10 years for trending, and retain all versions of system studies. Digital twin technology enhances NFPA 70B compliance and enables predictive maintenance. A digital twin is a virtual replica of physical electrical systems that simulates, predicts, and optimizes performance in real time. Applications for NFPA 70B compliance include initial equipment condition assessment, providing a real-time system overview, documentation management through a centralized repository for single-line diagrams, studies, procedures, and manuals, predictive maintenance analyzing sensor data to predict failures before they occur, maintenance scheduling with automatic tracking of intervals and work order generation, training and simulation in a safe virtual environment, and compliance auditing with instant access to all required documentation. ENS Grounding Solutions offers advanced digital twin capabilities using DEG software for 3D electromagnetic modeling, resistance to ground calculations based on soil resistivity, step and touch voltage analysis for personnel safety per IEEE Standard 80, fault current distribution to identify weak points, EMI and corrosion analysis, and frequency spectrum analysis in both time and frequency domains. Managerial responsibilities vary significantly by facility type. For high-voltage facilities including substations, power plants, and solar farms, ensure grounding grids meet IEEE Standard 80 step and touch voltage limits. Maintain protective relays and high-voltage equipment per manufacturer specifications. Conduct arc flash studies updated every 5 years, and address harsh environmental conditions. For commercial buildings, protect building occupants and ensure tenant safety. Maintain emergency systems including lighting, fire alarms, and emergency power, and minimize electrical downtime to avoid business disruption. For industrial facilities, prevent production downtime from electrical failures, maintain motors, VFDs, and process control systems, and ensure compliance in hazardous classified locations. For institutional facilities such as hospitals and schools, maintain essential electrical systems for life safety, address aging infrastructure and deferred maintenance, and schedule maintenance during breaks to avoid disrupting operations. ENS Grounding Solutions provides comprehensive engineering and field services as your partner for NFPA 70B compliance. Our design and analysis services include grounding system design using DEG's 3D electromagnetic modeling, IEEE Standard 80 compliance analysis with step and touch voltage calculations, lightning protection system design per NFPA 780, and soil resistivity testing using the Wenner 4-point method. Our testing and commissioning services include ground resistance testing using the fall of potential method, grounding system commissioning and benchmarking, condition assessment of existing below-grade grounding systems, and non-invasive testing using advanced measurement meters. Our NFPA 70B compliance services include equipment condition assessments, electrical maintenance program development, training and consulting services, and documentation and record-keeping systems. We operate globally with headquarters in Laguna Niguel, California, an East Coast office in New Jersey via TGS Incorporated, and field services available worldwide. Why choose ENS Grounding Solutions? Our specialized expertise includes high-voltage electrical safety specialists, lightning protection and corrosion control experts, step and touch voltage hazard analysis, and grounding and earthing systems for all facility types. Our advanced technology features DEG software, a true 3D electromagnetic solver, resistance to ground and fault current distribution calculations, electromagnetic interference analysis, and frequency spectrum and time domain analysis. Our comprehensive services span engineering design and analysis, field testing and commissioning, NFPA 70B compliance consulting, and training with ongoing support. Our proven track record includes substations, power plants, solar farms, data centers, cell sites, factories, and commercial, industrial, and institutional facilities, with global operations and local expertise. Contact ENS Grounding Solutions today. Let us help you achieve NFPA 70B compliance.
EES Grounding Solutions, Incorporated.
28202 Cabot Road, Suite 300, Laguna Niguel, California, 92677. Phone 1-310-318-7151. Email info@esgrounding.com. Website esgrounding.com. Our services include grounding system design and analysis, soil resistivity testing, lightning protection system design, ground resistance testing, equipment condition assessments, electrical maintenance program development, NFPA 70B compliance consulting, and training and technical support. Schedule a consultation today for expert solutions in electrical grounding, lightning protection, and NFPA 70B compliance.